All right, dividing polynomials. We're going to do long division with polynomials, and we're going to do something called synthetic division with polynomials in section 5.4 in the book. So you have a book, you can look in it, you can look through the examples, it's all in color and everything, but these are the basics of the section. So we're going to do long division first. With long division, the things that you learned in elementary school with long division, we can apply to these polynomials down here. I'm going to take 5,280 and divide it by 15. So I'm going to set it up like this. It's also handy, I don't know if anybody ever did this with you, but if you do 15, 30, 45, 60, count by 15s, it makes this go a lot faster because you know how many times something goes in there and how much is left over and all that business. So does 15 go into 5? No. Does 15 go into 52? Yes. 15, 30, 45, so it goes 3 times. So we put the 3 here, then we multiply. 3 times this is 45. Then I pick up the red pen because I'm going to subtract. So I'm subtracting out the 45, and I bring down 7, and I drop down the 8. So does 15 go into 78? Yes. So we go not this many times, but this many times here. So it's 5 times. So I put a 5. 5 times 15 is 75. And I'm going to subtract. So I pick up the red pen, bring down the 3 and the 0. So 30, that would be 2 times. 2 times 15 is 30. And then I subtract that off, and I get 0, so this has no remainder to it. There's no remainder, so this is the answer right here. The answer to a division problem is called the quotient. The thing that did the dividing is called the divisor. And the thing underneath here is the dividend. So we got the divisor, quotient, dividend. Boom, boom. All right, so now we're going to apply these principles here to the algebra part of it. Same kind of stuff. So basically, we need to divide. We kind of, this part follows along here. So we just take x and we divide it into this first thing. Or said differently, what times x makes 4x cubed? Because you see, every time we want this part to go away, because like 7 minus 7 was 0, 3 minus 3 was 0, and technically that's a 4 because of borrowing here. 4 minus 4 was 0. So we want to make the first thing go away every time. So we need a 4 and an x squared. This times this, we do the distributive property now. This times this is 4x cubed. This times this is minus 4x squared. All right, now I pick up the red pen because I'm going to subtract. So we're going to go subtract, and then we subtract a subtraction, which is adding. So this cancels out. This becomes x squared. Drop down plus 2x. So we drop the next thing down. What times x makes x squared? Well, I need an x, right? So I need to get rid of this first thing by subtraction. So I need to create that. So I need to create the x squared. So what do I have the x, I need an x more. So x times x makes x squared. X times 1 makes negative 1x. Like so. And I'm going to subtract with the red pen, subtract this. Now I'm subtracting the subtraction, which means I'm going to add it. So this plus this is now 3x. That cancels out, which is what I want to happen, just like here, and then minus 3x. Okay, so, oh, not 3x, just 3. I got a little crazy there. So I dropped down the 3. So this 3 drops straight down. Sometimes people drew arrows back in the day. So now I just need 3 up here. 3 times x is 3x. 3 times the 1 is the minus 3. And then I pick up the red pen to subtract. I subtract and I add. So this is going to be 0. So it has remainder 0. So this is the answer right there. There's the quotient to this. That's the answer up there. So I have 5 more for you to do. And notice on number 6 right here, I included a placeholder, because this would be x cubed minus 13x minus 12. Well, you need to account for all the places. So I had to add in a 0x squared there. So basically, these are all kind of the same. Let's do one more together. So like this one here is a lot simpler because it's x squared. So I need something times x makes 3x squared. Well, there's no 3 here, so I need a 3. And then what else do I need? What times x makes x squared? Well, I need the x. And the whole point of this is to make this first thing go away every time with subtraction. So you create this. So this times this would be 3x squared. This times this is 12x. Then I subtract with the red pen. So this goes away, which is what I want. And then 7 minus 12. 7 minus 12 is negative 5. All right. Then we need a negative 5. Because I have the x, I need a negative 5. So it's negative 5. So negative 5 times x is negative 5x. Negative 5 times this is negative 20. So I have to create this first thing, and it just so happened that this created here. So this and this is going to be subtracting. Subtraction changes those to addition. These 100% cancels out, and there's that. Number 4 has a remainder to it, and you can tell which ones have remainders because I put a little dot there. I'll show you how to handle the remainder on a different problem, and you can apply that right here. So number 4 has a remainder, number 11 has a remainder, and number 9 has a remainder. So I'll do one of those for sure. The next kind of thing is called synthetic division. Synthetic division turns the division world upside down. So that's the first thing we do here, is we make an upside down division sign, division bracket thing. And we always change this sign right here. So change sign. So that has to be changed. So, and then we just strip away the coefficients to do this. So instead of dividing by x minus 1, we just divide by 1. So that seems kind of weird. And what that does for us, instead of subtracting every time with the red pen, I get to add every time. By changing this sign, I get to add every time instead of subtracting. Now I strip away the coefficients. 1, 3, that would be negative 1, and 3, negative 3. So it's 1, 3, negative 1, negative 3. Okay. Demama is how you remember how to do this. You drop the first number down, you multiply, add until you're done and you run out of steps. So this first number, we drop this down. Then we multiply. 1 times 1 is 1. We put it underneath here. Then we add it together. 4. Then we go back to multiply. 1 times 4 is 4. We add these together. 3. We multiply again, 3. We box in the last number because it is the remainder. The remainder is 0. So if this is the remainder, this is the number term, this is the x term, and this is the x squared term. So 1 is x squared, so we write 1x squared. 4 is x, so we write plus 4x. 3 is the number, plus 3. And that's the answer, no remainder. So dividing this with long division, synthetic division saved us time. That's the answer. You don't have to have that 1 there. I'm just like letting you know that it means 1x squared. So you can leave that off, just x squared plus 4x plus 3. All right. So here's how this goes again. And I'm going to go through this one more time, and I'm going to put it over here in this space. Okay, so you can see how to do this again. So we change the sign here. 1. If you can just watch this time instead of doing it with me. 1, 3, negative 1, negative 3. So you write down the coefficients. 1, 3, negative 1, negative 3. And because we change the sign, we get to add every time instead of subtracting every time, which makes it easier because adding is easier than subtracting. It just is. So we drop, we multiply, we add, we multiply, we add, we multiply, and we add. All right. So this is the x squared, that's the x term, and then that's the 3, and that's the answer right there. Okay, so I did it twice just to kind of show you how you drop, you multiply, you add, you multiply, you add, you multiply, you add. All right, so this one has a remainder, so we're going to go through this one to show you what to do with the remainder situation. Change the sign. So we go -4. 1, -7, -7, and 20. We drop this down. We multiply. We add. We multiply. We add. We multiply. This times this is -148 bucks is the last number, and that would be 148. You owe $148. You pay 20. -128. All right. So x is squared. X is squared. So that's the squared term. Minus 11x, that's the x term, plus 37 is the number term. Now the remainder is a fraction, so remainders need to be expressed as a fraction. So like if you have a pizza and you have one piece left, right, that would be like 1/8 of the pizza. That's a fraction, that's the remaining part of the pizza. So we're going to change this to minus, with the negative there, we're honoring that, 128 over what I divided by, x plus 4. So I'm dividing a pizza by 8, so it'd be 1 piece out of 8. I'm dividing this by x plus 4, and then that's the part that remains out of the x minus 4. So this would be the answer to this one. So when you have an answer, whenever you have a remainder, you make it a fraction. Put the number over what you divided by, and it's either positive or it's either addition or subtraction based on whether that's positive or negative. Okay, so now we're going to completely factor. So there's 4 questions here on this part. So, oh, and by the way, when you set up this one here, you need a placeholder. You need to put, I need to go over that with you. You need 1 here, and then there's no x squared, and then there's no x, and then there's 27. So you need 2 placeholders on this one. And then this one here, there's no x term. So you need 1, and there's no x, and then 3, and then you go from there. But you need the zeros there, otherwise it won't work. Okay, and I kind of indicated that right here. That's a placeholder. If that 0 isn't there, it will not work. All right, this is, we're going to completely factor this. So we're given 1 factor, so we know that this divides into here because it is a factor. So this will divide into here evenly. Change the sign, -1, 1, 2, -5, and -6. We drop it down. We multiply, we add, we multiply, we add, we multiply, the remainder is 0. Okay, so what does this mean? This 1 here means 1x squared. This 1 means x. That means 6. And then we're going to multiply by x plus 1. So this is the factor that was given. Now we can completely factor this by factoring this part here like we've done 100 times. So 6 is what? 2 and 3? And then the positive 1 in the middle, so plus 3 and minus 2. All right, so there it is, factored completely. So we use the synthetic division to break it down to this quadratic, and then we break it down even farther. Why are we going to do this? Because in the near future we're going to set these equal to 0 and find the 3 solutions. So this comes from some equation, we set it equal to 0, etc., etc. Okay, the last problems have to do with, I forgot to do the introduction here. We need the dividing skill to do problems in the future, which I kind of indicated there. Okay, so the remainder theorem is what this last thing is about here, and plugging a number into a polynomial and looking at the answer is the same thing as synthetically dividing by that number and looking at the remainder. So these are the same thing, and I'll prove that to you right now. So what this is saying is take -2, the number, and put it into the function. So it's p of -2, which would be -2 to the 3rd power plus 4 times -2 squared minus 8 times -2 minus 6. So if we cube this number here, we would get -8. That would be 4 times 4, 16. That times that is 16, and then minus 6. So let me see. This would be 32 minus 14. 32 minus 14 is 18. So that and that is 8, 24, yeah, 18. So this is 18. So if I put -2 into this function, I get 18. Now watch what happens when I divide by -2 synthetically. Now, since this is the number, we don't change the sign. When it's the little binomial, right? When it's the little binomial x plus 1, we change the sign to be -1, because this would look like x equals -1 if you like solved it over. But here, it's already it's like x plus 2, and it's been moved over already, so it's like -2. So I'm going to synthetically divide by -2. Don't change the sign on this. So -2, and I'm going to have 1, 4, -8, and -6. So we drop this down, we multiply, we get -2. We add these two together to get 2. We multiply to get -4. We add these two together, -12. We multiply these two together, and we get 24. We add those together, we box it in, and what do we get? 24 minus 6 is 18. So I drop it down, I multiply, I add, I multiply, I add, and then I get 18. Look, these answers are the same. Okay? Which means I don't have to do this part anymore. Just synthetically divide. So just synthetically divide by -2, and you get the answer. So all in all, P of -2 is 18. And I can get this two ways, by putting the number into the function and by synthetically dividing and looking at that answer. And that's what the remainder theorem is, and that's going to be very important to us when we try and solve these higher level degree polynomials, which is the next section 5.5 and 5.6. All right, peace out.